Hello everyone, this video is on vision programming for software update version 2.2. So we will go to the vision tab and you can use any webcam you want. I am using this eMeet 960 webcam that I got off of Amazon. And so when you start the software, it should pick up all the cameras on your system and you can select the camera you want to use. Select start camera, that'll turn the camera on. This screen over here on the right gives you a live view of what the robot sees, or what the camera sees. The robot needs to be at the top of your picture. The orientation, the way you orient the camera is important. The robot needs to be at the top, and when the robot moves in the X direction, it should be moving in this way that I'm moving the mouse, and then it should be in the Y direction, should be moving this direction. And I have that also shown up here on the border of our workspace. So I can click snap image and that will grab a black and white screen grab from the camera. That's not a live view, that's just a screen grab one at a time. So the first thing we want to do is zoom in on our workspace. We want the wherever we want the pick area to be to kind of fill up the majority of the area. So I'm just going to zoom in a little bit there. So that's we'll go a little bit more. So that's pretty good right there. And now the next thing we want to do is to start working through the calibration. So we're going to calibrate pixels to millimeters, and to do that, in the software folder there's a vision grid you can print out. It can be any size. I'm going to put the vision grid over my pick area. You can see here. Now it's important that on this vision grid that the X1, Y1, the Y2, and the X2 position, that those fall over the backdrop, the color. You can see here I've got a conveyor that's black with silver on the edges. I don't want any of those dots to fall on the silver areas, and the reason is when we teach these pixel positions serve two purposes. One, for the calibration, but also for our background color, because when we go to mask out everything we don't want to see, it's going to grab those positions, those pixel positions, and grab the color there to choose our masking color. So I will hit snap image there to bring up a new screen grab, and all I have to do is, you can see right now that all these values are 0. If I come over here and I bring my mouse and I center it right over X1, Y1 and I left click, it'll automatically grab those pixels and put them into those fields for me. And then I will go to X2 and click, and it will grab that value and put that in the X2 field. And then I will click here on the Y2 value and it will put that in the Y2 field for me. So now I have all of my pixel positions taught. The next thing I want to do is put a pointer in the robot gripper. So you can see here I've got a little 3D printed pointer, and this part file, you can find this in the miscellaneous print files under the downloads. So with the pointer installed in my robot gripper, I've jogged the robot over the X1Y position. As you can see here, I have the pointer tip right over that dot on my calibration grid. So we'll go back to the main controls tab, and we'll look at our values here for our X and our Y. Something to keep in mind, I have the gripper perfectly straight up and down. So, you'll want the RY to be close to 180 and your RZ and your RX close to 0. Just to indicate that the pointer is vertically straight up and down over the target. So you can see here we're at about 325 in the X and negative 276 in the Y. So we'll go back to our vision tab, and for the X1 position we will put in 325, and for the Y1 position we will put in negative 276. So now I have jogged my robot over the X2 position, so the pointer is directly centered over the X2 dot, and our value in the X is 499. So I'll come back here to the vision, and for the X2 position I'm going to put in 499. And now I've jogged my robot to the Y2 position and have the pointer over the Y2 dot. And we can see that our Y value is at -93. So I'll come back to the vision and put in -93. And we can click save on that. And so now our calibration is saved and our pixel to millimeter conversion calibration is complete. So I've jogged the robot out of the way and we're done with the calibration grid, so I can remove that now. The next thing is to work on the to set the contrast and brightness, and one thing I wanted to mention was lighting. It's important to have really good even lighting over the top of your work area with as few shadows as possible. You can see here I've got a couple shadows which are not ideal, but I'm using a ring light over my camera, which I think seems to work the best, so I highly recommend doing the best you can to get as even lighting as possible. It's very important. So the next thing to do is I'm going to put an object in the field of view that is going to be my target object, just to help me identify the contrast. So I can snap an image over that, and we want the background to have as few shadows as possible and to be as even as possible. So I'm going to adjust the contrast until I start to get a really dark background, and we'll reduce the brightness. So now we've got a really good contrast between our piece. The background looks nice and dark. And we can now, once we have that where we want it, again, we can hit save to save that. And then when you open and close the program, all these settings are saved: your zoom, your brightness, your contrast, all your calibration values. So every step I save where I'm at. And then the next thing is the mask. To mask the areas that we're not looking at. We don't want the vision to get any erroneous, finds from finding, other shapes or pixels around the exterior. So what we can do is just create a box around our pick zone where we want to pick. And what that does is that it will just save that area as our pick area, and it'll mask out everything else. And it will use, like I mentioned earlier, it'll take this X1, Y1, X2, Y2, all of these positions. It'll take each of those positions that we taught, and it will automatically grab those as our background color to mask this out. Now, if you have trouble with that and it's not working, you can unclick the auto and you can enter in any value you want there. So for example, if I were to, if my background was a different color, let me do a screen grab of that and then open up Paint, and I'll paste in a screen grab of that. And then if I use the color picker and I pick a color, you can see that I've picked black, and that is 000. If my background was white, it would be 255, 255, 255, or if I pick like here the floor, you can see that's 99, 97, 73. It's black and white, so all three numbers are going to be the same for a black and white image. But the conveyor, for example, is about 84 without the contrast and brightness setting. So if you had a little bit of a grayish background that was 84, you could come in here and put 84, 84, 84 in here. The auto seems to work pretty well, but I just wanted everybody to have the ability to manually set the background color if you need to, if you want to, but I'm just going to leave that on auto. So now that we have our calibration done, we've got all of our brightness and contrast and everything set, we can actually teach an object. I want to get the object as straight as possible. So that looks pretty good. And we can click Teach Object and we can draw a box around it. I've had the best luck making the box fairly good size around the part so that I capture a good amount of the background color around it. If any shadows are cast, or if there's any lines on your conveyor belt or anything like that, I've had better luck having more background color than less. So I will save this. It's a keystone jack, so I'll just call it jack and hit OK. And so now all of the parts that I've taught should show up in this list, so I can select jack and it will show me what I'm looking for. And then when I hit snap and find, it will put crosshairs over it. And you can see on these crosshairs there's a little dash at the end to show you which direction is 0. So now when I move the object around and click snap and find, it finds it, no matter where we put it in the field of view. So the score threshold, if you're trying to find similar parts and it's finding the wrong part, we have a score threshold that can help you filter out finding the correct part. So what I typically do is just take the object out of the field of view, and you can see here's the found scored value. So if I do a snap and find and it's not in the field, it can't find it. If it can't find anything above our score threshold, right now it's set to 65. Right now it thinks that it found the object at a score of 50. So what it's looking at is it found enough of this black background to think that it found it somewhere in here. So I'll just do several snap and finds and just kind of see where the minimum value is. And it seems like 51 is the highest I've seen, 52. So it looks like 52, let's call it 55. So if I put in a score threshold of 55, that should be a pretty good value. That should be, that value is going to be as low as we want to go to find the part. So now when I put the part back in the field of view, it found it at 99. So that's just a way of trying to figure out where our minimum score threshold is. Usually somewhere 70 to 80 is probably best, but just showing you there what you can do to find the minimum score threshold. So a couple of the other settings here. We have this full rotation search. That was something I was using for some initial testing, and it might come in handy for for doing some testing and setup. But basically, currently I have an algorithm written that does kind of a smart search that splits the difference in the angles and searches fairly quickly and should be able to find the angle within 15 tries. This full rotation search will search every single angle all the way around, so it's a lot slower and not always as accurate. So I don't really think anybody will need to use the full rotation search. The pick closest 180, what that is reduces the robot's rotation. So if you have a part, you have a parallel gripper, and you don't necessarily need to pick the part at specifically at 180 degrees. You can leave this checked, and I would suggest leaving that checked if you can. I guess to better explain that, I've got these plier jaws I'll try and use to simulate a gripper. But this part, I could either grip it this way, or the robot could flip around and grip it this way. If the part is specific and you need to grip it a certain way, if it has to be gripped with, say, the north end of the gripper towards the shallow end of the plug, then you would want to deselect pick closest 180 and unselect that. So let's say that my part is rotated to, let's say, 135 degrees. Now, if I have pick closest 180 off, the gripper is going to rotate a full 135 degrees to pick it, so that the north end of the gripper is at the tip of our part. Now, if I have closest 180 on, basically what it's saying is it doesn't really care if the gripper picks it this way or if the gripper picks it this way. It's a mirrored part, so it doesn't matter. So with this selected, instead of moving 135 degrees in that direction, it's going to go the shorter distance and only go 45 in this way to pick the part. So that's what closest 180 does. Now, if I have that deselected, keep in mind that due to the limit switch on axis 6 to be able to have the auto calibration, the rotation of axis 6 is limited to 155 degrees in either direction. So the pick angle, when this returns a found angle and the robot comes to pick it up, all of that rotation is a tool offset. It's based on the rotation of axis 6. So if I have this pick closest 180 off, and the and my part is beyond, let's say it's like 170 or 175, the furthest that axis 6 can go is 155. It won't be able to get there. So if you have pick closest 180 off and it's beyond the robot's capability, it's not going to find it. It's going to give you that the part wasn't found. So then you can also select try closest when out of range, and what that'll do is the robot will go to 155 degrees and it'll be a little bit off, but maybe it can still get it. So that gives you a chance to still grab it if it's out of the rotation range for the robot. Now down the road, I may see if I can set up an option to remove the limit switch and let you manually calibrate axis 6 to get a full 180 in both directions, which would probably be ideal. That's not in there yet, but that might be a future feature. But I've had the best results when I can pick the part either way with my gripper and leave closest 180 on. So now let's get into creating a robot program to pick the parts. I'm going to go to the main controls tab, and I've created a program called Vision Example, just a blank program. So at the top of my program, I want to turn the camera on. That will turn on whichever camera is selected. And when you save vision data, each time the program opens, it will default back to the saved camera. So it'll always open this camera, and your program will turn on that camera. There's basically two things we need to do. We need to find the part, and then we need to pick the part. And along with picking it, we'll place it or do something with it. So here at the top, tab number 1, I'm going to hit Get Selected. I'm going to change that to tab number 0 and replace that. And then I'm just going to put in a comment that this section of code is to find part. So I'll put that right here. So tab number 0 is where we're going to find the part. And just for readability, I'm going to insert a few blank lines. And then we're going to find two parts actually. So I'm going to, so we're going to call this section pick part 1 and insert that. And then we need pick part 2, insert that. And then I'll just insert a few blank lines in between there. So under find part, under tab number 0, the first thing I want to do is move my robot to an approach position. And I have the robot right now jog to a position right in front of the conveyor. So I'm on move J, and I'll just hit each position. So that's my approach. If I want to, I can hit Get Selected, and I can overwrite this star with the word approach so that I know that that's my approach move. And then what I'll want to do is do a vision find for our first part. And so what we have here under the vision find function is if it finds it and passes, we want to go to a tab that's going to go pick the part. If we fail, we want to go back to the top and try it again. So if let's see here, so for pick part number 1, I'm going to create a tab number 1, and I'll put that there. And then for pick part number 2, we'll create tab number 2, put a tab there. So we have a place to jump to for our first part, and we have a place to jump to for our second part. So up here under the vision find, if it passes for our first part, we want to go to tab number 1. If it fails, we want to jump to the top at tab 0. So I'm just going to click that, and what that's going to do is it's going to go grab in this line of code. You can see it says jack.jpg. So because I have Jack currently selected, that's what it's going to put in the line of code. I can, of course, I can grab that line. I can grab that line and edit it and reinsert it if I want to. But I put in its background color set to auto. score is currently at 55, and then if it passes, it's going to jump to tab 1. If it fails, it's going to jump to tab 0. So now the next thing we're going to do is for part number 1, we want to go pick the part. So from this drop down, I can come down here and select Move Viz, and then on tab number 1, I can select Teach Position. Now before I do that though, what I want to do, so here on the Vision tab, we'll want to place our object in the field of view, and we want to put the object straight up and down so that when we hit Snap and Find, that the found angle, we want to make sure that that found angle is at 0 degrees, because every pick from here on out, when it goes to pick the part, it's going to be based on a pick position that's taught at 0 and a part at 0. So we need to make sure that the pick is taught at 0 degrees. So now you can see I've jogged the robot over the part. I've centered the gripper over the part and set it at a good height to pick the part. So now that I have the robot in a good position, I can come back to the main controls tab, go under tab number 1 where we're going to jump to when we pick that keystone jack, and I can hit Teach New Position for Move Viz. So one thing to keep in mind, that all of the Move Viz is always offset by position register 1, and the reason for offsetting it by position register 1 is to allow us to offset to approach above the part and then come down to the part to pick it. So I'll show you that here in a second. It puts in the current X and Y value for where the robot is right now, but those don't mean anything. When it actually goes to pick the part, the Move Viz function will throw those away. It'll throw away the X and Y, and it will replace them with the robot's X and Y position where it actually found the part, and then it will also offset it by that found angle right there. We also have the rotation, that it will use these rotations however you teach it. It'll use those rotations. So with the part at its 0 position in front of the camera, the gripper also needs to be at its 0 position over the part. And then of course you can set your track position, speed, acceleration, deceleration to any values that you need. And then I think I skipped over the height. It'll use the Z height for how high you pick the part. So that's the Move Viz. So now let's say that I want to actually move above the part. I don't actually want to move to it. So I'm going to come back here, and right before that Move Viz, I'm going to take position register number 1, and element 3 is the Z height. So if we go to registers, these are just position registers that store an X, Y, Z, yaw, pitch, and roll value. The third one in is the Z, and so what we want to do is offset that position in the Z by, let's say, 25 millimeters. So I'm going to insert that right there, and so now when I execute that line of code, when I come here to position registers, it sets the Z value to 25. So now when it actually executes this Move Viz, it's going to come 25 millimeters above the part. So now what I want to do is now that I'm above the part, I'm going to set it back to 0. So I'll set that position register back to 0, and then I'm going to hit Get Selected on that, insert it right there, and so now it will move. It'll set the position register to 25 millimeters high. It'll move 25 millimeters above the part. It'll set it back to 0. When I execute that move, it'll move right down over the part. So now the next thing I want to do is close my gripper. So I have output number 8 wired up to the solenoid valve that controls my pneumatic gripper. So I'm on the wrong line there. I want to set output 8 on. So that'll turn on my gripper. That'll grab the part, and then I'll want to move back up. So I'm going to again set my position register 1 back to 25 or any height that I want. So I'll hit Get Selected on that and insert that. I'll hit Get Selected on the move and insert that. So now I've gripped the part. I've set my position register back to 25 millimeters up, and now I've moved up above the part. And then now I can program a couple moves to move somewhere else. So I'm just going to, from that position right there, I will just jog straight up in the Z, and I will teach a move J. And then I'm just going to move joint 1 over to the side for now and teach that position. And then right here is where I'm going to drop the part. So then I'm going to set output 8 off. And so now I've released the part. And now what I want to do is jump back up to the top to tab number 0 and move back to my safe approach and look again for a new part. So right here, I'm just going to put jump to tab 0, and now it will jump to the top and repeat that process again. One other thing that I forgot here is that at the approach, before we go get the part, we want to make sure that we open the gripper. So I'm going to set output 8 off right up here near the approach. So now let's hit play on this. The camera's already on, so we'll just start the program right here and hit play. You can see here it's going to take a picture and find it, and the robot will go down 25 above, down to a pick it, come up, and then bring it over and let it go. So we'll come back to the Vision tab, and you can see it's just flashing red. It's just looking for the part. It's looping through the program. So as soon as I put the part in the field of view, it will find it, and the robot will go get it. So I'm going to hit stop. And so now if we wanted to find a second part, so what I'm going to do here is I'm going to copy and paste everything from tab number 1 down into tab number 2. So now I've copied everything from tab number 1, everything to pick that part, down to tab number 2 to pick a second part. And then of course I can modify these positions to place the part in a different spot. But the thing we'll need to do now is to add a second VisFind. This is for the jack part. So let's just let's hit get selected on that, and let's just insert it. And actually let's change jack. I have another part that's a plug, so I'm just going to change that to, let me take caps lock off there, change that to plug, and we will replace that line. So now I have one VisFind for jack and one VisFind for plug. Now for plug, if it passes, I want it to go to tab number 2 instead of tab number 1, so let's change that. So now we've got the plug. We're going to jump to tab number 2. The score, you may want to, be careful on your scores and make sure that your threshold is set correctly so that you avoid any issues. And so now the next thing we need to do is right above this VisFind, I need to create a new tab. I'm going to do, we've already used tab 0, 1, and 2, so we'll just do tab 3 and create a tab right there. And so now on this first VisFind, if it fails, I don't want it to jump back to 0 because it's just going to sit here in a loop and constantly look for the jack. It'll never look for the plug. So I want to get that one. And so if the jack fails, I want it to move down to tab number 3, and I want it to look for the plug. So I'll replace that line of code. So what it'll do is it'll look for the jack. If it doesn't find the jack, it'll jump to tab number 3. It'll look for the plug. If it does find the plug, it'll jump down to the section of code for picking the plug. And if it doesn't find the plug, it jumps back to the top and looks again for the jack again and just cycles through this. So this is how you would set up a program to find multiple different parts, and you could set this up for finding as many parts as you want. So one other thing here, this plug is a little bit shorter than the keystone jack. So I've gone in here into the pick position. Instead of picking at 0 on the plug or on the jack, we just set it to 0 to where our top position was. So if I want to just reuse this code without reteaching the position, I just copy pasted all this code, and then my pick position I can just adjust it. So I made it -10, so it comes down a little bit lower than picking the plug, or picking the keystone jack, excuse me, to pick the plug. And then the other thing was the score threshold. I had a little bit better luck setting these to 65. So now if I come up here to the top of the program and hit play, the program's just going to sit here and cycle through, and when I put the plug in place, it'll come in and find the plug. So it'll just continue searching there, and then so I can put the jack in the field of view, and then the program will find the jack and the robot can go grab that part. So that's the majority of teaching and picking apart, but I had one other topic I wanted to cover real quick. I wanted to come back to this pick closest 180 and try closest one out of range. So if you do need to pick the part in a particular orientation, and that axis 6 rotation of 155 degrees could become problematic, I would recommend teaching the part a little bit differently. Since the picking of the part, the found position is a rotation of axis 6 when it gives this angle, when it returns this angle. If you're trying to pick at a specific position, you might have better luck if you actually teach the pick with the part at the robot's axis 6 0 position. So basically what I'm going to do is I'm going to jog the robot down over the pick area, and I'm going to rotate axis 6 to 0. So I'll do that now. So now I've jogged the robot down over the workspace to a good pick position for the part, but I'm making sure that axis 6 is at 0 degrees. So you can see here with the robot in this position, the gripper isn't square to the conveyor because my robot base is not perfectly lined up with my conveyor, and that's kind of what I wanted to talk about here. So now if I jog the robot up and out of the way, so I placed a part in the jaws with the axis 6 at 0 degrees, and then jog the robot out of the way, and you can see the part is not straight up and down. That's how the part would sit with J6 at a perfect 0 degrees. So what I want to do in this case is I'm going to go ahead and teach the keystone jack while it's at that orientation, and I'll just call that jack 2 and hit OK. And so now when I select jack 2 and hit snap and find, that is going to be, even though the part's not sitting perfectly straight to the crosshairs, that is going to be the 0 position for the part. So the 0 position for the part will perfectly match the 0 rotation for J6. So now with the part taught like this, I'm going to have the best opportunity to rotate a full 150 degrees to the right or 155 degrees to the left and have a better chance for picking that part. So I just wanted to kind of cover that topic if you are needing to pick the part at an exact orientation. So that's everything I have for this tutorial. Shoot me an email if you have any questions, and thanks for watching.